Video we are going to cover formulas for surface integral of a scalar function and examples. A surface integral is a two-dimensional extension of the line integral concepts used to integrate over a one-dimensional curve. Surface integral of a scalar function for a smooth surface S defined parametrically as vector ru comma v is equal to fu comma v I gu comma v j plus hu comma v k, where u comma v belongs to R, and a continuous function gx comma y comma z defined on S. The surface integral of g over S is given by double integral over R. So double integration gx comma y comma z d sigma is equal to double integration g of fu comma v comma gu comma v and hu comma v is equal to modulus of ru cross rv du dv. For a surface S given implicitly by f of x comma y comma z equal to c, where f is continuously differentiable function with S lying above its closed and bounded shadow region R in the coordinate plane beneath it, the surface integral of continuous function g over S is given by the double integral over R, double integration g d sigma is equal to double integration g modulus del f by del f into p vector dA, where p vector is a unit vector normal to R and del f dot p vector not equal to 0. For a surface S given explicitly as a graph of z equal to f of x comma y, where f is continuously differentiable function over a region R in the xy plane, the surface integral of the continuous function g over S is given by the double integration over R, double integration g d sigma is equal to double integration g x comma y comma f x comma y and root of fx square plus fy square plus 1 dx dy. This formula change according to graph of x is equal to f y z and z and y is equal to f x comma z. So according to graph of function, this formula will get changed. So example, evaluate double integration 6xy ds, where s is a portion of the plane x plus y plus z equal to 1 that lies in the first octant and is in front of yz plane. Solution: since the portion of the plane that lies in front of the yz plane, we are going to need to write the equation of the surface in the form of x is equal to g of y comma z. So we have x equal to 1 minus y minus z. So writing the plane of equation in this form, this is our region D. Therefore we have 0 less than or equal to y less than or equal to 1 and 0 less than or equal to z less than or equal to 1 minus y. You can find the limit in this way. This is the axis y and this is z and this is a line y plus z is equal to 1. When we solve this in terms of z equal, it will be equal to z equal to 1 minus y, and taking here the vertical strip, the lower limit of z is equal to 0 here, z equal to 0, and upper limit is 1 minus y. Similarly, when we move it left hand side, so y is equal to 0 here and y is equal to 1 here. So by this way we can find the limit of y and z. So we know that double integration f ds is equal to this according to formula, because here x is a function of y and z, so we are going to use this formula. Then putting all this value here in this formula, right hand side will be this, and then solving this integral, double integral, will get these steps, and when we put the limit, we'll get this term, and finally solving this integral and putting limit will get the final answer root 3 by 4. Next example, evaluating double integration gx comma y comma z d sigma is equal to double integration x square d sigma over the cone z equal to root x square plus y square, where z lies between 0 and 1. Solution: the parameterization of cone z equal to root x square plus y square for 0 less than equal to z less than equal to 1. So vector r comma theta r cos theta I plus r sin theta j plus rk. This is the value of x, this is the value of y, and this is the value of z. And the limit of r lies between 0 and 1, and limit is theta lies between 0 and 2 pi. So we have to find del r by del r. So the value of del r by del r is this. Value of del r by del theta is this. And then we have to find cross product of del r by del r and del r by del theta. So we'll get this vector. Then we'll find the modulus of this cross vector. So it will be equal to r root 2. So now we have to apply the formula. So applying the formula, this formula, and putting all this value here and solving this step by step, will get these steps, and we'll get pi root 2 by 4. That is the final answer. Next problem, double integration y d sigma, where s is the portion of the cylinder x square plus y square is equal to 3 that lies between z equal to 0 and z equal to 6. The parameterization of the given cylinder is vector r z comma theta is equal to root 3 sine cos theta is the value of x, I plus root sine theta j, this is the value of y, and z equal to z. These are the cylindrical coordinates, where z lies between 0 and 6, it is given in the question, and theta lies between 0 and 2 pi. So we will find the del r by del z, that is equal to k, and del r by del theta, that is equal to this. So we will find the magnitude, which will be equal to root 3, and then we will find the del r by del z cross del r by del theta, which is equal to minus root 3 cos theta I minus root 3 sin theta j, and we'll put all these value in this formula, and solving this step by step, we'll get the answer 0. So the double integration y d sigma is equal to 0. This is the final answer. Thank you. Link of PPT is given in the description box.